Hello, everyone. Today we are starting to finally truly prove triangles are congruent. So, fortunately, we do not need to prove or show that all the triangles are congruent. We do not need to show all 6 facts are true. There are certain combinations of the facts that are sufficient to prove that triangles are congruent. These combinations of facts guarantee that if a triangle can be drawn with this information, it will take on one and only one shape. Only one unique triangle can be created, thus guaranteeing the triangles are congruent. So today we're going to learn our first 2 methods, and that is SSS, which stands for if 3 sides of one triangle are congruent to 3 sides of another triangle, those 2 triangles are congruent. SAS, which is if 2 sides and the included angle of one triangle are congruent to the corresponding parts of the other triangle. The included angle is the angle formed by the sides being used. So it's really important that when we're talking about SAS, that we have side, and then the angle touches that side, and then that angle touches the other side. Because you will see, as we explore this idea, that not all combinations of angles and sides work. It has to be the included angle. So, draw a triangle and then label the vertices A, B, C. What angle is between BC and AC? Hopefully you see that's angle C. Then what sides include angle B? Well, angle B is in between AB and BC. Hopefully you are noticing a trend, that it's the letter that's in both sides that's the included angle. What angles include AB? Well, that would mean that angle A and angle B are the 2 angles that include AB, meaning AB is in between those 2 angles. What side is included between A and C? Well, that would be side AC. Again, the 1 letter. So now I want you to try these examples. And I want you to look at the triangles and decide if you have enough information to show they are congruent using side, 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 or side, angle, side. If so, I want you to write the congruent statement. So let's first talk about what that means. So if I look at number 5, I know that AB is congruent to BC, and I know that the angle ABD is congruent to CBD because that's what's labeled. Think back, we have to remember that we have the reflexive property, which means BD is equal to itself. So we could prove these congruent using side, angle, side. Now the triangles that would be congruent are triangle ABD is congruent to, and then we have to name them in the same order. So A would correspond with C, B, D, because BD is going to correspond with itself. This is the congruent statement. So I'm going to pause, and I want you to try to do 6 through 13, and then we'll come back and check them. Okay, so hopefully you gave these a try. Number 6 and 7 are not possible. 6, we only have 2 sides and no angles, so that's not possible. 7 would be side, side, angle, which backwards spells a bad word. Therefore, I can't write that on a math test. 8 would be side, 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 so it's triangle STU is congruent to triangle VXW. 9 is not possible because they truly only have 1 side and 1 angle. 10 would be SAS, so it's triangle CDE is congruent to triangle FGH. 11, we have to keep in mind that KM could be reflexive, so that would be side, angle, side, and then side, angle, side. So that'd be triangle JKM is congruent to triangle LMK. 12, again, PR is reflexive, so we have side, side, side. So it's triangle PQR. It's congruent to triangle PNR. And 13 is not possible because, again, we could have vertical angles here, but again, that would be SSA or backwards. So it's not possible because backwards SSA is a bad word. 14. So now we're going to try to do these two proofs, and then we have one coordinate proof. So for this proof, we know that HF is congruent to HJ, and then we know that JK is congruent to FG. And last, we know that H is the midpoint of GK. So that right there tells us our other piece of information that we really need to know to do this. So H is the midpoint of GK. That means that GH is congruent to KH. And that's definition of midpoint. And then if we look at our two triangles, we're trying to prove FGH is congruent to JKH. So purple, blue, pink, which we have in both triangles. So our last step is triangle FGH is congruent to triangle JKH. And our reason is SSS, side, side, side. Number 15. We know that KJ bisects GJH. So KJ bisects angle GJH, which means the angle GJK is congruent, forgot my angle symbol, to angle HJK. And that's the definition of the angle bisector. Then we were also given that GJ is congruent to JH. And then if I look at my drawing, I know that JK is congruent to JK because of reflexive. So this is where I really need to write that because I need it as my third side or my third piece of information. All triangles need 3 pieces of information to prove them congruent. So now I have pink, blue, purple, where the blue angle is included between the pink and the purple sides. So that means triangle JKG is congruent to triangle JKH by side, angle, side. And our last example for today. So I want you to pause and I want you to plot the points, and then we're going to determine if the triangles are congruent or not. So I want you to think about what you can show on a coordinate grid to figure out if these triangles are congruent. And then come back and I'll do it for you, but definitely plot it first. So I'm looking at those triangles and I got to think about what are things I can find on a coordinate grid. I can't really find an angle measure unless they're perpendicular, but that would only tell me one angle is a 90-degree angle. But I can find how long each segment is. So what I want to do is I want to do the distance formula, which remember is d equals the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. And I want to find out how long each side of both those triangles are. So please pause again and do the distance formula, what amounts to 6 times. Okay, so I did all my distance formulas. I found out that PQ is the square root of 18, as well as JL is the square root of 18. So I'm going to label those two congruent. So PQ is congruent to JL. And then I know that my other sides are all congruent because they're all equal to the square root of 17. Therefore, since both those triangles are isosceles, I really could name it two or more different ways. What's really important is that PQ has to match up with JL. So I'm going to say triangle PQN is congruent to triangle JLK. And again, this one, because those are isosceles triangles, I can really flip-flop those letters around, but PQ has to match up with JL. Okay, if you have any questions, this is the end of our video. Tomorrow we'll work on these problems in class, and have a good day.